Hello dear students, in last classes we discussed about radius of nth orbit of an atom, velocity of an electron in the nth orbit of an atom, angular velocity of an electron in the nth orbit of an atom. Okay, so what is the formula used to find the radius of nth orbit of an atom? So that formula is Rn is equal to 0.53 into n square by z, so unit is angstrom. 1 angstrom means 10 to the power of minus 10 meter. Suppose to be we are going to find the radius of the first orbit of hydrogen atom. First orbit means n value is taken as 1 and for the hydrogen atom the atomic number is 1. Okay. Then 1 square by 1 again it is 1. Then radius of the first orbit of hydrogen atom is how much? That is 0.53 angstrom. Then radius of second orbit of the hydrogen atom. Suppose second orbit means n is how much? 2. 2 square is 4 and z is 1. 4 into 0.53 you will get 2.12 angstrom. Okay, so it is the radius of the second orbit of hydrogen atom. Then how the radius is related to the principal quantum number? The radius is directly proportional to the square of the principal quantum number. The square of the principal quantum number. And here n takes the values from 1, 2, 3 and so on. Okay. Then next, what about the velocity of an electron in the nth orbit of an atom? So that is Vn is equal to 2.18 into 10 to the power of 6 into z by n meter per second. Here the velocity is measured in meter per second. And here the radius is measured in angstrom. Okay. Then how the velocity of the electron is related to the principal quantum number? That is related inversely. So Vn is inversely proportional to the principal quantum number. So what its meaning? In the higher orbits, the electron will be moved with lower speed. So in the higher orbits, the electron will be moved with lower speed because they are inversely related. Okay. So next one. What is the angular velocity of an electron in the nth orbit of the atom? That is omega n is equal to omega naught into z square by n cube. Then what is omega naught? Omega naught is nothing but here 8 pi cube k square into e raised to 4 into m divided by h cube. Then already we know that value of pi, that is 3.14. Pi value is 3.14. And what about k value? K value is 9 into 10 to the power of 9. K is nothing but 1 by 4 pi epsilon naught. What is the value of 1 by 4 pi epsilon naught? That is 9 into 10 to the power of 9. Then what is the value of E? That is 1.6 into 10 to the power of minus 19. Then, so what is the mass of the electron? M is nothing but here mass of the electron. Mass of the electron is 9.1 into 10 to the power of minus 31, that is in kg. Then what is the value of h? H is nothing but Planck's constant. The Planck's constant value is 6.63 into 10 to the power of minus 34, that is in joule second. And by putting these values in this term, means this formula, we will get the answer, that is 4.159 into 10 to the power of 16. So we are going to substituting these values in this formula. Then we will get omega naught is equal to 4.159 into 10 to the power of 16. I will substitute this omega naught value in this equation, then we will get the equation omega n is equal to omega naught is how much? 4.159 into 10 to the power of 16 into z square by n cube. And here the angular velocity is measured in radian per second. So angular velocity is nothing but the angular displacement per time taken. Angular displacement measured in radian and time taken is measured in second. That is why the angular velocity is measured in radian per second. Linear velocity measured in meter per second, but the angular velocity is measured in radian per second. And for the hydrogen atom, the z value is how much? 1. And in case of first orbit, n value is 1. In the first orbit of hydrogen atom, what is the angular velocity? That is omega 1 is equal to 4.159 into 10 to the power of 16 radian per second. Because for the hydrogen atom, z value is 1 and for the first orbit n value is 1. Then 1 square by 1 cube, again it is 1. Okay. Then now we are going to discuss about the time period of an electron in the nth orbit of the atom. Time period of an electron, it is also neat application. Time period of an electron in the nth orbit. In the nth orbit of an atom. So let us consider there is an atom. For example, I will take the hydrogen atom. So this is the hydrogen atom, and at the center of the atom the nucleus is present. So nucleus is positively charged. The charge on the nucleus can be taken as plus Ze, and an electron is revolving around the nucleus in the nth orbit. So let us assume this is the nth orbit. So this nth orbit may be first orbit, second orbit, third orbit, or whatever. Okay, I will take in generally nth orbit. An electron is revolving around the nucleus in which orbit? Nth orbit, with the velocity that is Vn, that is linear velocity. Okay, then the radius of the nth orbit of the atom, that is Rn. Okay, then the charge on the electron is taken as e raised to minus, means minus e. Then, so what is the angular velocity of the revolving electron? Angular velocity of the revolving electron is omega n is equal to omega naught into z square by n cube. But our aim is to find the time period. So by using the definition of angular velocity, we are going to determine the time period of an electron in the nth orbit of an atom. See here, what is angular velocity? So angular velocity is nothing but the change in displacement divided by time taken, or angular displacement divided by time taken. See here, angular velocity. Angular velocity. So what is the definition of angular velocity? Angular displacement divided by time taken. So what do you mean by time period? First of all, we have to know what do you mean by time period. So time period is nothing but it is time taken by the electron to complete one rotation. Okay, in the nth orbit. What is time period? So time period is the time period is the time taken by the electron. Time taken by the electron to complete one rotation. So what is time period here? Time period is the time taken by the electron to complete one rotation. Okay. So now, what is angular velocity? It is the angular displacement in one rotation divided by time taken. So what is the angular displacement in one rotation? The angle covered in one rotation is 360 degree. In terms of radian, that is 2 pi. So I will write it is 2 pi. And time taken to complete one rotation is called time period, and time period is represented by capital T. But what is our aim? Our aim is to find time period. Then T is equal to 2 pi divided by omega n. I will interchange. So I will take this omega n to the right hand side and T to the left hand side. Then T is equal to 2 pi by omega n. So what is omega n? By using this formula. So 2 pi divided by omega n is nothing but omega naught z square divided by n cube. Here n cube is in denominator, that comes to the numerator. I will write this equation as 2 pi n cube divided by z square, and it is 2 pi by omega naught. Okay. So this 2 pi by omega naught is a constant value. So 2 pi is a number, 2 into 3.14, that is 6.28, and omega naught value is known. What is the value of omega naught? That is 4.159 into 10 to the power of 16 into 10 to the power of 16 radian per second. It is the value of omega naught. Okay. So now, so 2 pi means 6.28. 6.28 divided by 4.159 into 10 to the power of 16, we will get that is 1.5. And this answer is about 1.5. And this 10 raised to 16 is in denominator, that taken to the numerator, that becomes 10 raised to minus 16. 10 raised to minus 16 n cube by z square. N cube by z square. So this is the formula used to find the time period of an electron in the given orbit. In the first orbit of the hydrogen atom, then n value is taken as 1. First orbit means n is taken as 1, and for the hydrogen atom z value is 1. Then 1 cube divided by 1 square, again it is 1, means in the first orbit of the hydrogen atom, the time period of an electron is 1.5 into 10 raised to minus 16 second. Here the time period is measured in second. Okay, means the time period is directly proportional to the cube of principal quantum number. Okay, so this is about the time period of an electron in the nth orbit of an atom. Okay, so how the time period is related to principal quantum number? The time period is directly proportional to the cube of principal quantum number. Okay, this is about the time period of an electron in the nth orbit of an atom. In next class, we are going to discuss about energy of an electron in the nth orbit of the atom.